So, hello, bonjour, welcome everybody to our webinar. Happy World Water Day. My name is Lauren Clark and I'm a project coordinator with EOS Eco Energy. EOS is an environmental charity that has more than 17 years of experience working on community-based projects related to energy conservation, efficiency, renewable energy, sustainable community planning, climate change adaptation, and watershed health. Just a few housekeeping notes. So if you have any questions that come up during the presentation, feel free to type them in the chat so that you don't forget them, and we'll do our best to get to them during our question and answer periods. And so I'm just going to let a couple more people in. Yeah, so without further ado, I'd like to introduce Miranda, who's going to start things off with her presentation on water quality monitoring.
Thank you very much, Lauren. And welcome everyone, and thank you for joining us on your lunch break today. I'm here on behalf of EOS Eco Energy to share the results of our 2021 water quality monitoring program in the Tantramar River watershed. The work was carried out by myself. I was the water quality project coordinator for the first time this past summer, Catherine Premer, the EOS Watershed Project summer intern, and Sarah Arthur and Samantha Croft, two Mount Allison University Campbell Lab student assistants. And EOS would like to respectfully acknowledge that our work is done on the traditional unceded lands and waters of the Mi'kmaq people. So, water quality. What is it and why should we care? Water quality describes the physical, chemical, and biological characteristics of the water. Maintaining the quality of surface water is essential for a healthy watershed, and we all rely on healthy watersheds for clean drinking water, for food production through agriculture, for industry, and tourism. EOS has been monitoring water quality in the Chignecto watershed since 2018, thanks to funding provided by the New Brunswick Environmental Trust. So just to summarize our study area, the Inner Bay of Fundy watershed composite is comprised of three sub-watersheds: the Tantramar River watershed, that's this big one here, the Rockport-Dorchester area, and the Missaquash River area. So the Tantramar River watershed is the largest watershed in this composite, covering 410.4 square kilometers of land area. The Tantramar River watershed borders the Cape Tormentine Peninsula watershed to the north, which is part of the larger Northumberland Strait watershed composite, the Missaquash River area to the east, and then Rockport, Dorchester, and Memramcook River watersheds to the southwest. The Tantramar River watershed is focused around the Tantramar River, whose headwaters start northwest of Cookville and wind down to the Trans-Canada Highway, Highway 2, near Sackville, New Brunswick. So the watershed has another larger fourth-order river, the Olac River. Both rivers ultimately flow into the Cumberland Basin of the Inner Bay of Fundy. The rest of our watershed is made up of a series of smaller brooks and creeks. Land use in the Tantramar River watershed includes agricultural and forestry activities, residential and commercial developments, municipal sewage lagoons and private wells, and the Tantramar National Wildlife Area. So the Tantramar River area was last monitored in 2018 during the first year of the EOS Water Quality Monitoring Program. Water quality samples were collected from 12 sampling sites that were selected to represent a mix of impacted versus less impacted sites. So by impacted sites, we mean areas that have been more developed, such as by roads, residential or farming properties, cleared fields and pastures, etc. So the Tantramar River sites, Silver Lake Outflow, Morris Creek, and La Coupe River, those are all examples of more impacted sites, versus the less impacted sites have more pristine environments with intact forest buffers, such as East Brook, Harper Brook, Musquash Brook, Robinson Brook, and Reservoir Brook. In situ water quality parameters were measured in the field from May to October using a HANA multi-parameter meter. That's this dangling device here that Catherine is holding in the river. And this photo here is of Catherine, Samantha, and Sarah collecting measurements at Robinson Brook in July. So the measurements that this instrument collects are pH, temperature, conductivity, dissolved oxygen, total dissolved solids, and salinity. And I'm going to be going through 4 of these parameters in the following slides. Bottle samples were also collected from June to September, so for 4 months, and they were brought to the RPC laboratory in Moncton for the analysis of water chemistry, metals, and bacteria for a total of 59 parameters. Samples were also brought to Dr. Justin Leifer's lab at Mount Allison for the analysis of chlorophyll A. So, our in situ results. Water temperature. Water temperature is dependent on a number of factors, including geographic location, season, time of day, velocity or speed, width and depth of the water body, riparian vegetative cover or the plants that are growing on the edges of our rivers and streams, and human impacts. So higher water temperatures mean that less oxygen can be dissolved, which has implications for aquatic life such as fish. The summer of 2021 was relatively warm and dry with a wet July, and water levels were generally normal across sites. July had the highest surface water temperatures with an average of 17.9 degrees. So according to Environment Canada recommended guidelines, water temperature of streams should not exceed 20 degrees C. So over here on this plot of water temperature and monitoring location, there is a red horizontal line that shows our 20 degrees C cutoff. And we saw that that cutoff was exceeded at 2 sites in August, so at Morris Creek and at the Silver Lake outflow. This is in contrast to 2018, where water temperatures were found to exceed guidelines 18 times. So in general, we observed higher water temperatures still in our impacted versus our less impacted waterways, but just not as high as what we saw in 2018. pH is a measure of how acidic or basic the water is, and neutral levels, so a pH of around 7 is best for fish. And according to the Canadian Council of Ministers of Environment, Ccme, their guidelines, the ideal pH for surface water to support aquatic life is between 6.5 and 9. Most of our pH measurements were within these Ccme guidelines. So here's our plot of pH and monitoring location, and we have this horizontal cutoff at the 6.5 point, just to show to indicate where the guideline level is. And you can see at most locations at the end of the season, we had some drop off of pH, but in general, all of our bars are up over the line. The exception was Eastbrook, where we saw some low pH measurements, but this sampling site is downstream of a wetlands with acidic peat deposits, which might explain these lower pH values. Dissolved oxygen, it's the amount of oxygen dissolved in the water that's available for aquatic life. And the New Brunswick Water Quality Guideline for the Protection of Aquatic Life is 6.5 milligrams per liter of dissolved oxygen. So here we have on our plot, this is the 6.5 milligram per liter cutoff. So as water temperature increases, the levels of dissolved oxygen decrease. And the highest dissolved oxygen levels were seen in May and October, which makes sense because the seasonal water temperatures were lower. So dissolved oxygen was found below limit at 6 sites in June, August, and September. So you can see here, Eastbrook, La Coupe River, and then our 3 Tantramar River access point sites all had dissolved oxygen levels below limit. But there were still far fewer dissolved oxygen flags recorded this field season compared to 2018. So we had 10 flags in 2021 versus 22 flags in 2018. And the final in situ measurement I'm going to discuss today is conductivity, which is a measure of the ability of water to carry an electrical current. So conductivity is dependent on dissolved inorganic solids like ions and also temperature. And it is used to calculate the total dissolved solid and salinity measurements that I also listed in the earlier slide of our in situ measurements. So I'm just going to report here on conductivity today. So there are currently no water quality guidelines for conductivity, total dissolved solids, or salinity in New Brunswick. But all three were typically higher in our more impacted rivers and creeks, with the exception of Harper Brook, which also had higher values. So you can see here that LeCoupe River had the highest values of all. We also had some high conductivity measurements in Harper Brook, again in Morris Creek, Silver Lake outflow, and also in the 3 Tantramar River sampling sites. So next, I just want to give you a little snapshot of our bottle sample results. So some of the most important measurements that came out of those samples from RPC, the RPC lab in Moncton. The first is total phosphorus. So phosphorus is a component of many important nutrient compounds that are used by plants, such as phosphates. And it can be present naturally due to geological formations or decomposing organic matter. However, it can also enter waterways from fertilizer runoff, manure storage, wastewater treatment effluent, and leaching septic systems. New Brunswick has a total phosphorus guideline for the protection of aquatic life of 0.03 milligrams per liter. And that line is indicated here on the plot. Again, this is our dotted red line. So you can see that the guideline was exceeded many times for 31 out of 48 samples. Many sites were eutrophic, which means they fell in between the 0.035 and 0.1 milligrams per liter total phosphorus, and 8 sites were hypereutrophic, meaning above this 0.1 milligram per liter cutoff. So the Tantramar River at Double Culvert had our highest, I mean, you can see it's just totally right off the chart, highest phosphorus levels. And the thing is as a key nutrient that can lead to increases in algal growth and decreased dissolved oxygen in our waterways, it's an important parameter that we would like to investigate further. So bacteria that live in the digestive tract of warm-blooded animals can be represented by E. coli or Escherichia coli. And they're used to indicate the potential presence of harmful organisms. So the presence of these fecal indicators could mean that there are other disease-causing pathogens present, such as bacteria, viruses, or parasites. The Health Canada single sample maximum guideline for Canadian recreational water quality is 400 E. coli per 100 mils. So here's our limit up here on our plot, the upper limit from Health Canada. So you can see that the guidelines were exceeded at only 2 of the 12 sites in July. Again, at LeCoupe River and the Tantramar River at Covered Bridge. So July was a warm month, and we sampled 3 days after a significant rain event, and that could have led to a higher concentration of these bacteria being flushed into the river. And in 2018, in comparison, we reported 4 samples over the limit that were all at LeCoupe River in 2018. And chlorophyll A. So chlorophyll A is a green pigment that's found in plants, and it's required for photosynthesis. And we use it as a measure of algal biomass. So algae is a critical component of the aquatic food web, and it also provides habitat for aquatic insects and fish. Algal biomass can increase under excess nutrients such as phosphorus and nitrogen. Too much algae can lead to declining dissolved oxygen levels and in some cases, harmful algal blooms. There are no water quality guidelines that currently exist for chlorophyll A in New Brunswick. However, monitoring chlorophyll A is still important for understanding the algae levels and potential impacts in the watershed. All right, so now I'd like to talk briefly about metals. Metals are introduced into the water from weathering or erosion of soils or rocks, either naturally or due to human activities. Most surface water metals that we looked at this year were well below detection limits. The exceptions were iron, aluminum, zinc, cadmium, and lead. So iron and aluminum levels exceeded the CCME guidelines at all sites except for Harper Brook. But New Brunswick is known to have higher levels of naturally occurring aluminum in soils, and runoff from rain events or snowmelt could cause aluminum and also iron to leach into the waterways from the surrounding rocks or soils. Zinc levels exceeded CCME guidelines at 7 sites, and Joe Brook and Morris Creek had zinc levels over limit for the entire season. This is compared to 2 sites in 2018 that had zinc levels over limit. Cadmium levels exceeded CCME guidelines 7 times at East Brook, Joe Brook, Silver Lake Outflow, and Reservoir Brook. And this is versus 3 times in 2018. Lead levels exceeded guidelines 3 times at East Brook and Morris Creek versus 2018, where no levels of lead were observed over limit. So Joe Brook and Silver Lake Outflow are popular fishing spots, and it would be good to further investigate the sources of these metals. So I just wanted to show you, this is a table of the metals data with the over limit values highlighted in red. And this is this kind of table helps us to quickly visualize patterns and recognize problem areas. So here, for example, these columns that are largely filled in with red, that's aluminum and iron. And then we have zinc, which was apparent at about half of our sites. And then we see the flags of cadmium here and lead. So yeah, it's just a helpful tool for us to visualize the metals distribution. And finally, we have the CCME Water Quality Index. So the Canadian Council of Ministers of the Environment Water Quality Guidelines uses this index to combine multiple parameters into a single value that summarize water quality at a site. It is calculated based on scope, which is the number of specific variables that don't meet the water quality guidelines, the frequency, or the number of individual tests that don't meet the guidelines, and the amplitude, or the amount by which the failed tests do not meet the guidelines. So the index provides a consistent reporting scale across Canada, and the index for a given location can be compared year after year and provide a quick visual check-in on watershed health. So the scale ranges from excellent, where the water quality is protected with a virtual absence or threat of impairment, all the way down to poor, where water quality is almost always threatened or impaired. Now, for an accurate water quality index, a site is required to have 4 samples per year with at least 4 variables measured. So we did the minimum of 4 samples per year in our watershed. So this is the kind of results we get when we perform this index calculation. We saw that 5 sites fall into the fair category. These are the orange bars. We saw La Coupe River had the lowest water quality index at 67.8. One site came out as excellent water quality with 95% at Musquash Brook. And on average, our index was 83.4 this year, and that's compared to an average of 65 that we. And it suggests that 2021 was overall a better year in our watershed, with fewer high temperature and low oxygen flags to drag down the water quality index. In conclusion, the summer of 2021 was generally warm and dry with a wet July, and water levels were typically observed as normal across sites. In general, we observed higher water temperatures, lower levels of dissolved oxygen, higher levels of total phosphorus, higher conductivity, total dissolved solids and salinity, and higher levels of bacteria at our more impacted waterways, such as the Tantramar River sites, Silver Lake Outflow, Morris Creek, and La Coupe River, versus our less impacted ones, the brooks and streams. Surface water metals iron, aluminum, and zinc are found at high levels at many sites in the Tantramar area, and some cadmium and lead flags do exist and warrant investigation. Overall, the state of our watershed health is good. However, we do have some sites with problems that could be addressed in the future. So EOS would like to expand the knowledge of our watershed through the collection of more data. Cabin data is benthic macroinvertebrate data, sort of the bugs that live in the sediments, hydrological data, riparian health data. For example, an assessment of La Coupe River would be very helpful, and also fish and habitat data. And EOS will continue to engage with community members and landowners to promote watershed best management practices and improve riparian buffer zones. So things like greening the shoreline, so planting native plants next to shorelines to reduce erosion and sedimentation, fencing of watercourses near farms, maintenance of domestic septic tanks, reduction of chemical inputs such as reducing the use of lawn pesticides and fertilizers, reducing impervious surfaces, so using less pavement, and also picking up after our pets. These are all things that that just any of us can do to help protect our watershed. EOS hopes to return to the Cape Tormentine Peninsula area this summer in 2022 to obtain a second year of data in this watershed area. It was last sampled in 2019. There's always room for water quality improvement and more work that could be done. So this was my first year working with EOS to do this monitoring program, and I just want to take a moment to acknowledge some of the people that made this possible. So our funders, New Brunswick Environmental Trust Fund, also members of the Chignecto Watersheds Committee for their expertise, our summer student intern, Catherine Premer, and also Dr. Doug Campbell's students, Sarah Arthur and Samantha Croft. They came out water sampling and processed chlorophyll A samples and assisted with the data entry. Mount Allison has loaned us sampling equipment to assist in our long-term water monitoring program. Dr. Campbell and Naman Omar at Mount Allison University provided our scripting support. Dr. Justin Leifer at Mount A, again, allowed the use of his lab to filter and analyze our samples for chlorophyll A. Laura Chandler from St. Mary University's Atlantic Water Network provided us with the R script and supporting documents to calculate the water quality index. And finally, Patrick Sinclair from the Gordon Foundation's data stream has provided continued data support.
So, hi, my name is Lauren Clark, and this is my presentation on the habitat assessments that I and Catherine Premer did this summer on Joe Brook. And we would like to thank the New Brunswick Wildlife Trust Fund for the funding to be able to do this project last summer. All right. So in the summer of 2021, EOS conducted some stream habitat assessments of Joe Brook, which covered 7.7 kilometers. So like I was saying, in the summer, after looking at our data, we divided the stream up into 3 sections in order to better analyze it. And so those sections were upstream, midstream, and downstream. So first, looking at the riparian zone conditions, and the riparian zone is the strip of vegetation that lines the border of the water body, so in this case, Joe Brook. So on average, the riparian zone conditions were relatively healthy with some problems, including high amounts of slight erosion and low shade cover, which affected the overall scores. Average bank conditions had high amounts of slight erosion for the first 2 sections of the stream, so upstream and midstream, on both sides of the bank. Combined averages of shrub and tree cover remained above 49%. And downstream, the field residential section had the lowest average shade cover with 17%, which was likely due to the grasses and shrubs having the highest percentage of vegetation cover. So you can see in some pictures here, Like I mentioned before, there were some high levels of slightly eroded banks, and also some low amounts of shade cover, which we documented. So now moving on to channel conditions. So overall, channel conditions were relatively healthy. We had a high percentage of rock for all 3 sections of the brook, between 42 and 64%. And then the downstream section of the brook had relatively high percentage of sand at around 30%. All other substrate materials were found in relatively low quantities comparatively. So things like bedrock, gravel, fines, things like that, they were quite low. The average percentage of fines was between 6 and 10% for all parts of the brook. So moving on to aquatic habitat conditions. So aquatic habitat conditions across all sites demonstrated average water temperatures between 16 and 17 degrees Celsius. And I should mention that for these parameters, we also used a HANA probe to take in situ values. So we looked at the things Miranda talked about earlier. So temperature, dissolved oxygen, pH, average conductivity, total dissolved solids, and salinity. And we took those measurements every 100 meters along Joe Brook. And I also just wanted to say, for all dissolved oxygen values, they remained above 6.5 milligrams per liter. And we had an average of 9 milligrams per liter in all 3 sections of the brook for dissolved oxygen. pH was an average of 7. As well, average conductivity, total dissolved solids, and salinity did not indicate signs of saltwater intrusion, which was good. And then the average reach composition run was the highest percentage that we found, with over 50% in all 3 sections of the brook. And so this is our point system that we used to evaluate the different reaches and if they had the potential to be restored. So when I say reach, I mean a section of stream that was 100 meters. And what we did is we took measurements every 25 meters along that reach and averaged the data. So the more points a reach has, the greater potential it has to be restored. And like I mentioned earlier, we divided the stream up into 3 sections. This is the top section upstream, where we did 30 assessments. And most sites, or 67% of them, were designated as healthy with problems. So they had between 4 to 6 points. 10 sites recorded less than 25% shade cover. 4 sites recorded vegetation consisting of 60% more or more of grasses. And 19 sites recorded that 40% or more of the bank was slightly eroded. And so of these 30 assessments, only 1 had a total score of 0, meaning that it was in good condition, while the remaining sites could benefit from potential restoration projects. So the remaining 29 sites ranged in number of total points, and 9 sites, or 30%, were categorized as healthy. So the green section there. Okay, so this is the midstream section, which consisted of 34 assessments. And most of the sites were designated healthy with problems. So the orange color there. So we had 21 sites that recorded 40% or more of the bank that was slightly eroded. And we had 5 sites recorded that over 25% of the bank was heavily eroded. And of the 34 assessments, only 1 had a total score of 0, meaning that it was in good condition, while the remaining sites could benefit from potential restoration projects. And then 8 sites were categorized as healthy. You can see the green on the map there, not very many. And one site, the red there, was designated as unhealthy. Okay. So the final section of the stream was the downstream section. You can see the Mount View Road there. And this consisted of 13 assessments, 5 of which were designated as healthy with problems. That's the orange section. 10 sites recorded less than 25% shade cover. And 4 sites recorded that 40% or more of the bank was slightly eroded. And of the 13 assessments, none had a total score of 0, meaning that all of the sites could benefit from potential restoration projects. Okay, so potential projects could include tree planting in riparian zones for sites with stream banks that were bare of vegetation or had large amounts of grassy vegetation. Large debris could be removed from the stream. Cleanups could be organized of dump sites. The construction of brush mats along silty stream beds is something that could be considered, although there were very few sites in Joe Brook with high levels of silt. There were a couple sites downstream with sand, but this wasn't really impacting the visibility. So the water was still clear in those spots. Something else we could do that EOS could do in the future is to run a campaign to engage landowners along Joe Brook in order to establish healthy buffer zones. So buffer zones as narrow as 8 meters on one side were observed, particularly upstream, and the buffer zone is the area of like vegetated land on either side of the brook. And there were places upstream where there had been logging, where they had logged quite close to the stream, and there was a spot where trees were actually falling like down the bank into the stream, which is not super great. So there's me and my water sampling habitat assessment GitHub. So yeah, that's the end of that presentation for me, but I would be happy to answer any questions that anybody has. I hope everybody has a lovely day, and thank you so much for tuning in and listening to our presentation. Miranda, did you have any last words?
I just thank you all for your time and for coming out, and feel free, if you think of any questions later or anything at all, feel free to reach out to Lauren and I. We're always available via email, phone calls, whatever. So thank you.
Yeah, absolutely.